let's get started. So before I start, I just want to say I go with the flow. If you guys have questions, if you all have questions while I'm going through, please feel free to ask at that time. Just shout out, my name's Tom. Just say, hey, Tom. I like that back and forth better than me just regurgitating to you and then you forget what you want to ask and you have to wait until the very end. So please feel free to ask questions as I go. Who am I? So originally I had a hashtag, who am I, like you would put in Unix, but they changed it, unfortunately. My name's Tom, as I said. I've been at Splunk for 7 years, almost 8. I've been a sales engineer, partially a sales rep during that time because our sales reps tend to go and flow. And then I became a security strategist. So if anyone is a Splunk customer and has played Boss of the SOC, which is our blue team exercise event that debuts at Conf, I've been the lead on that the past 2 years, 6 and 7. And 3 years prior, I was a content creator. So if anyone has ever played it, I did a lot of the UBA stuff. In version 5, I actually created an AWS specific scenario for bots, which this is based on. I am based north of Boston. I live in Maine, so I know people who are not very familiar with New England geography. I say Maine, and people think I'm, 6 hours away. It's about an hour north. It's just north of Portsmouth, right over the border. Lights coming back up. Okay. I've worked at Splunk, obviously. I've worked at Core Security, which used to be a security company in the Seaport area here, doing core impact and penetration testing. Worked at Mimecast, which is an email security company based out in Waltham, but it was originally founded in London and South Africa. And Symantec, I feel like everyone has worked at Symantec at one point or another. And Raytheon is where I got my start, how I moved up here. I have a couple of certifications. You can look those up if you're really interested, but doesn't make me who I am. So let's talk about what we're going to talk about. So first, we'll talk about what exactly is server-side request forgery. I'll talk about how I recreated the event, what AWS gave us, or what AWS telemetry allowed us to see. What did we see with Splunk, or I'm sorry, how we got data into Splunk from AWS and other data. What did Splunk add to what AWS was telling us? And then finally, next steps for you all to experience some of the cool stuff that I'm about to talk about. So before I get into server-side request forgery, sorry about that. I realized I was stumbling over a lifesaver. I want to talk really quick about how this kind of data set and how this came about. So I mentioned Boss of the SOC. A couple years ago, specifically 4 years ago, the leader of Boss of the SOC, who is still at Splunk, said to me, we need an AWS-only scenario. So you're not allowed to have anything other than AWS telemetry. And I kind of said, well, that's going to take a lot of fun out of it because it's just AWS stuff, right? Like, how much is there inside of AWS from a security perspective? And what about all of this other data? Like, this is what we do. We're Splunk, right? We add a ton of data together with basic telemetry to get information and to get value out of it. He said, nope, AWS only. You can revisit it later if you want to, but for now, it's AWS only. So I started to look, and around, I want to say 2019, there was, and I'm going to say fictitious financial institution that was breached during that year. I can't say who it is, but if you happen to go to Google or Bing or DuckDuckGo or whatever search engine you choose and type in 2019 SSRF, you will get a ton of articles about it. This financial institution had a website inside of AWS that was properly secure, but poorly coded. And what happened is, if you're not familiar with a server-side request forgery, basically an attacker, or as AWS likes to call it, agent, will send a normal web request with some prepended code in it. It's almost like a SQL injection, but you're not injecting into SQL. You're actually executing commands on that instance. Everyone who's used AWS knows that AWS EC2 instances come with this awesome endpoint that you can interrogate to get every piece of information about your AWS environment. 169.254.169.254. I can kind of see a show of hands. Who has used that endpoint before? A few people? Okay, awesome. But what I can say is, if you happen to misconfigure something or have shoddy code, you can abuse that endpoint to your will, and that's what happened in this instance. So why is this bad, right? Why is server-side request forgery potentially bad? Well, in this specific instance, and this will kind of shed some light on what type of financial institution it was, but if you've ever applied for a credit card, everything that you apply with, your home phone, your address, your birthday, your mother's maiden name, social security number, bank account numbers, pretty much your entire life is stored in a database of credit card companies. And they were able to exfil over 100 million data points in this specific event. So that's why this is bad, right? So that kind of sets up what I looked at and what I wanted to recreate. So let's talk a little bit about how I recreated this attack. So just really quick, so that you can see, here are the 4 phases of the event or attack, as well as the MITRE techniques and tactics that are mapped to each phase. And this is just for your information. We're not going to spend too much time on this slide. So let's go into discovery. So like I said, a very poorly managed, not poorly managed, but poorly coded web application. And you can see at the top, I have obfuscated some of this data, but you can see at the top, basically I did a curl of that web page to a PHP page on that website, and I just put the path as that endpoint with some arguments. So I basically said, please give me the current security credentials that this EC2 instance is operating under. And this is what the web server gave back. Anyone think that might be bad? For a web server to provide that to anyone on the internet? Yeah. So, as anyone who has used AWS knows, I have everything I need in that response to log into that company's command line interface, right? I have the access key, I have the secret key, which I obfuscated, and I even have the token. You don't need the token, but I have the token too. So what did I do? Well, I created a Lambda function. And you can see the Lambda function here at the bottom. All I said was, hey, just give me access, secret, and session. And after the discovery and interrogation, I found that there was actually a role inside of this environment that anytime you executed Lambda functions, it executed as an all admin. So basically, I created this Lambda function. I executed it as an administrator. And I was able to get, within 5 minutes, admin access to this account. Again, really bad, right? So what is normally the next thing that an attacker would do after you breach into a system? Anyone? Go ahead. You don't have to raise your hand, just yell out. Maybe. So we're escalated already. What happens after escalation? There you go, persistence. So I have admin access in this environment. Let's create a user, right? And at the bottom, you can see that I didn't show the output, but the last command I ran, I gave that user I just created total admin access to the environment. So now I have a user with some password @3 that I can actually just log into the UI, the command console, command center, whatever it's called, and access everything inside of AWS's console through the UI. Now, I'm a UI guy. I'm not a command line guy. So for me, this was the first thing I wanted to do. I wanted to get UI access so I could go in and start breaking stuff. So after persistence, let's do some data exfil. I just went in and unblocked all of their S3 buckets, right? Public access for everyone. Interesting point, you can see that I spun up T2 micros. This was more of a proof of concept that I could do it, but I could have spun up, GPU intensive machines. Interesting tidbit, if anyone has ever tried to spin up 250 GPU intensive machines in AWS without telling AWS that you're going to do that, they won't allow you. So look on the bright side, right? You have to actually email them and say, hey, can I do this before they let you do it? And that's it. That was it. 20 minutes total with bad code. So what tools did I use? W3AF, which is really just a web scanner, right? Kali for obvious things. DigitalOcean, which is, I was using a Swedish-based Unix machine for external access. And then Paku, if you don't know about Paku, please definitely go take a look at it. It's a Git resource, but it's awesome. It's offensive, all AWS offensive security. Good? Everyone still with me? All right. Anyone ever seen this image before? No? Never? What's interesting about this image? Any thoughts? Oh. And? Yep. Everything I just did is not AWS's responsibility. And that's kind of the point of this, right? AWS delivers a ton of telemetry around what they're responsible for, but they don't care about your applications. They don't care if it's coded properly. I mean, they might care. They don't care if it's coded properly. They don't care if you happen to use a WAF or not. I'm sure that they would appreciate it because it would cost more, but like they don't, above that software line, they don't care, right? That's, what's that? Until 100 million credit cards are exfiltrated, yes, exactly. So let's take a look at what AWS did show us. And I'm showing you Splunk screenshots. I apologize. I didn't take screenshots out of AWS. This is a Splunk-sponsored presentation, so you're going to get Splunk screenshots. What can you see here? So this is coming in from Security Hub. You can see that the event is that credentials were created. So what does that tell you? Everything I did before I created that user, AWS doesn't know about. So I gained access to an AWS environment, and Security Hub didn't say anything. You can see the description of the event. The access key information is actually logged in Splunk as well. And then the instance details that I spun up in this instance, or where I was executing these commands. Guard duty, very similar. Expanded that out, and I get the S3 bucket unblocking. Again, I had already had access to the environment before guard duty said anything, which is interesting. CloudTrail data, very similar, quite honestly, and this is the stream of events. Now, if you know what to look for, you can see what's going on in this environment through CloudTrail, but nobody is really looking at this kind of stuff, unfortunately. We all have day jobs. We're not just sitting there looking at CloudTrail logs. CloudTrail logs. So you can see that I did get caller identity. That's basically AWS's version of who am I. I got a list of groups. I created the user. So what inside of AWS didn't show anything? CloudWatch data. Surprisingly, VPC flow logs didn't show anything. I thought that it would show something. S3 access really didn't show much until I turned off the block on public access, and then it just went crazy, which is not good because I couldn't figure out what was going on anyways because there was so much data coming in that if you've ever unblocked an S3 bucket, you know what I'm talking about. Your log files just, right? They're actively attackers out there scanning S3 buckets just for the heck of it. Config didn't say anything, and inspector didn't pop. Those are the only ones I really had set up from a security perspective. I could have set up some other things, but that was what I had set up back in 2019 to initiate this original scenario. Any questions so far before I switch to the Splunk part? Oh, sorry, I didn't. I couldn't find it. So the question was, if VPC flow logs were turned on, would it have shown the curl? I couldn't find it anywhere. I couldn't find it. And maybe it was a misconfiguration on my part, but I couldn't find it in VPC. Right. Right. Because I mean, I can curl a public website, right? That's how I test things from Amazon all the time. I curl to Google, or I ping Google. So yes, I didn't find it in VPC flow logs, but that doesn't mean it wasn't there. I mean, I searched all of this information for every step that I did. And as I was doing it, so as I was performing this attack on one computer, I had Splunk up on a second monitor, real-time streaming, so I could see what was happening inside of Splunk, and it never popped in VPC. So I'll have to go back and look at that, actually. Any other questions before we get to the Splunk part? Sorry, I'm not saluting you. I just can't see. All right, let's talk a little bit about getting data into Splunk. If you've used Splunk for a while, you probably know that getting data into our product is not necessarily the easiest thing in the world. And if you've ever tried to get AWS data into Splunk, you definitely know that it's not the easiest thing in the world. It involved a lot of configuration files, different settings for each different log type inside of AWS. Some of them came in through Lambda, some of them came in through CloudWatch. Some of them came in through this. Some of them go through our HTTP event collector. There was no rhyme or reason. It was almost like we started with CloudTrail, and then when we added Security Hub, we used whatever that moment's cool thing was. And then when we did guard duty, there was something else out, so we used that to get data in. We fixed that. And if you haven't seen what I'm about to show you, I implore you, if you are a current Splunk customer, please go out, ask your rep about this. So we developed something called Splunk Cloud Data Manager, where you actually just go up, click a button, what you want. You click what event you want from AWS. You type in your account number, and it just goes. It's a bunch of CloudFormation scripts, Lambda technology. I'll be honest, I'm not smart enough to explain it to you, but it does work. That's important. What's really cool about this is it's either one account or multiple accounts. You can actually set like your control tower account. I don't even know if it's still called that, but that's what it used to be called. And it will go out and get everything from all of your subsequent accounts. You have a question? So the question was, will we ever support Terraform instead of CloudFormation? I don't know the answer to that. I apologize. if you have your SE, ask you, or Seth is that Seth just sitting right there? I don't know the answer to that. We can find out. We can definitely find out. So, yes, sir. This winter. It's Splunk Cloud only currently. So that might be why you haven't seen it. Okay. Are you on? We'll talk. Yeah. So now, instead of the old way, this is how data flows into Splunk. And I know this seems super complicated, but it's actually 1,000% better than what it used to be. So Guard Duty, Security Hub, all go in through CloudWatch. If you need to send that stuff out to SOAR, you can through SQS. And then CloudWatch comes into EventBridge and Kinesis. And all of that data just flows right into our HTTP event collector, right into Splunk. So it's super, super, super easier. I'm not going to say it's the easiest it could be, but it's a lot easier than it was maybe a year ago. If you've not tried it in a year, it should be a lot easier now. Yes. The question was, are logs encrypted point to point? Yes. There is still that capability that we have for GDI of non-AWS, or for non-AWS. And I put this in here specifically because the next part we're going to talk about, Splunk added telemetry and how it helped in this incident. So what did I use? I used Stream and Apache logs. Now Stream is our wire platform, wire data platform. It's more robust than some other wire data platforms, and it's free, but it does chew license, so just keep that in mind. So let's talk about what Splunk added. Now, I love this picture because, funny story about this picture. If you haven't noticed lately at conferences, speakers are no longer using memes. Have you noticed that? All conferences, not just this conference, but we're not allowed to use memes anymore. And I found this picture on the internet, and I put it into my conference, our Splunk user conference session. I put it into my slide deck. And legal made me take it out because they said it wasn't my picture. So I took a Splunk shirt, put it on a table, took a picture, and edited "Oh my God, Splunk" onto it, and then they let me put it on. So, like, we're getting to the crazy parts, right? So let's just look. Everyone remembers the CloudTrail logs a few minutes ago that we looked at. Get caller identity, et cetera, et cetera. And we know that the first event that Security Hub notified us about was the create user, which happened at 12:35 p.m. That should be p.m., sorry, 12:35. So let's just keep that in mind, right? 12:35, 12:35, 12:35. If I say it 3 times, you'll remember. If we look at Apache logs, we can see that I was in the environment an hour and a half before AWS notified us. Which is, yeah, okay, it's an hour and a half. Big deal, right? I probably wouldn't respond to an actual attack within an hour and a half. So what's the big deal? Same thing with wire data. Hour and a half, right? So this is 10:40, 12:35. So that's almost 2 hours, but I'll be generous and say an hour and a half. Can anyone tell me what this is? Any ideas? Nope. No, sir. It's not scanning. What's that, sir? Sorry? Nope. The user agent? Oh. There's a reason that the user agent is there, but I mean, what's your guess? Okay. It wasn't. Any other guesses? Look at the time. The timing is important. Anything seem peculiar about timing? Yes. I'm sorry. Yes, that's true. They are 3 minutes apart, each one. Does that shed any light on what might be happening here? Nope. No, although that's a good idea. What am I doing? I'm doing a get caller identity, right? What is that in AWS? Right. Why would I do that every 3 minutes? So I did 180 seconds, right? Which is a little aggressive, but I kind of wanted to prove a point. This is my keep alive. I'm already in the session. I just want to keep it alive. Imagine doing that for a year or, a month. But then I got curious. 180 is very aggressive. What is the default timeout for command line access in AWS? Anyone know? If you can't read it, it's 12 hours. And if you keep reading the answer, you can actually go up to 36 hours. Is there any reason in the world that you would have a 36-hour timeout on a command line session? Well, yeah, laziness, that's a good one. So what did I do? Well, I showed you the Apache data. I showed you the stream data. So what does that do for me? Well, I started to kind of add in some of the premium products at Splunk, right? First, I added Security Essentials and ES Content Updates, which are actually free applications that are sitting on top of Splunk, specifically to detect AWS-only data. I set up a rule inside of Enterprise Security, but you could do it in Core as well, Core Splunk, to look at that metadata endpoint. Set up a rule to look for the 169 IP in URI redirects, which should probably never really happen. If you have a URL redirecting to that IP address, something bad is going on. Large amounts of hits to that security credentials path. That should not be something that your DevOps engineers are hitting on a daily basis. They should not be hitting that in their code. I know that they're going to say, oh, we use that endpoint all the time to develop our code and push things and do this and that, DevOps. But they should not be hitting the security credentials path of that URI. Alert on Lambda creation and deletion very quickly. Now that might trigger some things with the DevOps guys, because I know they spin things up and then they spin it down right away. We have new cloud security dashboards inside of ES. If any of you are enterprise security customers, I'll show you a screenshot of that. And then if you are bringing in VPC flow logs or stream, basically wire data, use the network traffic analyzer protocol dashboards inside of ES, and we'll take a look at that. So what did that produce? Well, this is nice. I get a nice notable event inside of Enterprise Security. Sorry, it's so bright. I can see everyone now. I get a nice notable event inside of Enterprise Security that says, I see a new user logged into the console. I see they're coming from a new city, new country, new region. And all of that created a notable event, a risk notable event, for the user that I had created from the command line. Now, the risk score is a little off, but I was just happy that it created something inside of Enterprise Security because I didn't configure anything. I just installed ES and it was there. Here's the dashboard. So again, some things to drill in on. Activity by user. If you have a lot of unknown activity, that's probably a bad thing. Bye, thank you. And then you can see here at the bottom, the create users. A lot of create users, actually. You can see, as you scroll down, you're going to see IAM error activity. I didn't take a screenshot of that, but you start to see some of the the red herrings that I left behind intentionally to pop inside of this dashboard. Now flash the next slide. Please don't everybody get up and walk away, all right? So what do I want you to take away from this session, right? We can help supplement that data that you're bringing in from AWS or that you're looking at from AWS. Remember the responsibility model, right? Everything above software, they're not responsible for. So everything that this attack occurred in, AWS ultimately wasn't responsible. Wire and application data are just as important, if not more important than infrastructure data. Please, 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 please use your web application firewalls. Test your code. That was the big one. That was the big gotcha moment for this company. And then be meticulous with your IAM strategy. No one needs admin all to run Lambda functions, but that's what happened in this instance. If you guys actually want to see this code or this data, reach out to your rep. We have it in demos. It's in bots, so you can watch, you can play with the data if you want to. We can give you access to the data if you want. All of this data is available, not free, but well, it is kind of free, right? I'll give it to you if you want it. But you need to have Splunk to view it. So that's the only gotcha. And I'll leave it at that. Questions? No questions. What's that? The question was metadata version 1 or 2? 1. And what? I did not try it with 2. I also, if you notice, didn't run this scenario with a web application firewall because I knew that it would outright block what I was trying to do. That's why, like, the very first thing that I say is use a WAF. But I needed it to allow me to do all this stuff to kind of create the attack. Any other questions? Oh, yeah. So what changes has AWS made since I built this data set? And I don't think it was because I built this data set. I mean, I'll take credit for it if someone at AWS wants to give me credit. But I believe in 2019, they still hadn't introduced web application firewalls across the entire AWS software. So different regions may have had it, but some of them didn't. They did release a new version of metadata, so I don't know if that is even still possible. Other than that, from what I can tell, not much, because I'll tell you, I did this originally in 2019, and if you saw, I did it again in April, and I was able to still do the exact same thing. Same code, same executions, same command lines, everything. So I would say that as of April, this is still possible. I don't think anything has changed since April that would block this. But again, if you are using web application firewalls, that 100% would have stopped this. Or maybe metadata version 2. I didn't try it with that, so it's possible that security credentials, all of that stuff that I used is not available there. Okay, all right. But what I will say is metadata 1 is still available. It is. So I don't know if you heard what he said. It's hard to migrate from version 1 to version 2 because a lot of applications just assume that those security credentials are there to pull. Yeah. Yeah. Any other questions? I will be here. We have 20 minutes, so please just pepper me with questions. If not, I'll stick around and chat with you privately if there's something that you want to ask me that you don't want to ask in public. I can do that as well. I'll put this up because It has my contact information.